recording for geometry, and this is section 6.6, part 2. And last time we had found the slope of segment AB, and then we were asked to find the rest of the slopes. So let me just kind of go over those quickly with you. For CD, x1, y1, and x2, y2. And so that is going to be 4 minus 3 over 2 minus negative 2, which is 4 minus 3 is 1, 2 minus negative 2 is 4. So those two are parallel, so that's one thing that we want to recognize. If both pairs of opposite sides are parallel, then it might be a parallelogram, and we want to see if it's a trapezoid or show that it's a trapezoid. So for AD, we have x1, y1 and x2, y2. So the slope of AD is going to be 4 minus 1 over 2 minus 5. And for that one, 4 minus 1 is 3. And 2 minus 5 is negative 3, and so we get a slope of negative 1 for that one. And then the last one is segment BC, and so if we call this one x1 and y1, and this x2 and y2, the slope is 3 minus negative 1 over negative 2 minus negative 3. And when we do that, 3 plus 1 is 4. And 2 plus 3 is 1, so we get 4 for that slope. So those two are not parallel, and I did opposite sides there as we go. And so for that part of it, we can say that it is a trapezoid. So we'll say ABCD is a trapezoid because segment AB is parallel to segment CD, and it is the only pair of parallel sides. So we have one pair of opposite sides parallel, so that is a trapezoid. Then the second part that we have to do here is we have to give this as, oops. We also have to figure out if it's an isosceles trapezoid. So that's our next part. And to figure out if it's an isosceles trapezoid, we're going to use the distance formula. And what we're going to do is we're going to see if, since we know it's a trapezoid, and maybe I'll mark these as parallel, we know those two are parallel. And then if it's going to be an isosceles trapezoid, that would mean that these two are going to be the same length. So that's what we have to do, is find the lengths of the legs. So part 2 is to use the distance formula. So part 2 is use the distance formula to find the lengths of the legs, to find the lengths of the legs. And so we have to identify what the legs are. We know these two sides are parallel, so the legs have to be these sides as we look at that. So just a reminder of our distance formula: D equals the big square root parentheses x2 minus x1 in parentheses squared plus parentheses y2 minus y1 in parentheses squared. And so then we want to find the length of these two things, segment BC or BC's lengths and DA. So take a minute, pause this, and use the distance formula to find those two things. So let's see what happened. For BC, we get the square root of -2 minus -3 in parentheses squared plus 3 minus -1 in parentheses squared. And that gives us the square root of 1 plus 16, which is the square root of 17. And then for DA, we get the square root of 5 minus 2 in parentheses squared plus 1 minus 4 in parentheses squared and the square root of all that. So that's the square root of 9 plus 9. So look at that. We get the square root of 17 for one of them and the square root of 9 for the other. So those may appear to be close to the same, but they are not. So it is not an isosceles trapezoid because the legs are not congruent. So since the legs are not congruent, ABCD is not an isosceles trapezoid. So make sure you've taken good notes so that you're going to be able to figure out what is happening in a problem like this as you move on. Now, pause this if you need to write more down, and then we'll move on. Okay, moving on. Here's problem number 3. And for problem number 3, we know the midsegment and one of the other sides, and we have to find the missing side. Okay, so this is number 3. In the figure, segment MN is the mid-segment of trapezoid FGJK, and what is the value of X? So we want to look at the formula then for the mid-segment. And if we look at that, we know that the mid-segment, which is BE, is equal to 1/2 of these two bases added together. So that's what we're going to do in this problem. Except here, we're going to know the mid-segment and have to find one of the bases. So by the mid-segment theorem, that mid-segment, which is MN, is equal to 1/2 of KF plus JG. So let's put in the numbers that we know. So the mid-segment is 30, and that's equal to 1/2, and KF is 20, plus GJ or JG, which is X. And we have to solve that. So the way we're going to do that is we're going to multiply each side by 2 to get rid of that fraction. And we could have distributed that, but that's the way that I wanted to do it. And so then that gives us that 60 is equal to, here these cancel, 20 plus X. And so when we subtract 20, we're going to get 40 equals X. And that is that length. Now, I'm going to clone this page and kind of just talk about some other things that we could notice here. So notice that if we found the difference between these two numbers, this is 20 and this is 30, that difference is 10. The difference here is 10. Is 10. And so between these two, the difference also has to be 10. And so we can say, oh, if that's 20, then this is 30, then that's 40. So sometimes we can do that in just a little different way, just to let you know as we go. Now, Let's move on to example 4. For example 4, this is a kite. There's 2 questions we're going to be asked, I believe, for this one. And I'm going to put them both on the same slide when we get to part B. So it says this is a kite, and we have to find the measure of angle X, Y, Z. So I'm just going to trace X to Y to Z just to know which one it is. This is the angle that I want to know. Now, there's a theorem here that says 2 angles are going to be congruent. Do you know which 2 angles are going to be congruent? Well, the 2 angles that are congruent are angle X and angle Z, so mark those as congruent. And that means that the measure of angle Z is also 121 degrees. And since a kite is a quadrilateral, the sum of the angles, of the interior angles of a quadrilateral is n minus 2 times 180, and so that's that's 4 minus 2 times 180. And so that's 2 times 180 or 360. The reason I go through that at this point is we're in section 6, but that was in section 1, and we are going to have to remember that for not just quadrilaterals. Quadrilaterals. I thought I had spelled this wrong, but it didn't hit me till right now. But it is quadrilaterals like that. And so the sum of the angles is 360. So we can add these 3, subtract from 360, and get that. So go ahead and do that, and we'll see what we come up with. Okay, when we added 121, 121, and 73, we should have gotten 315. And then when we take 360 and subtract 315, we should get 45. And so that means the measure of angle XYZ is 45 degrees. Now let's move on to part B. Maybe I will just go to the next slide. So for part B, this is a different picture of a kite, and we know that if we have a kite that the diagonals are perpendicular. So the diagonals of a kite are perpendicular. That means this is a right angle, this is a right angle, this is a right angle, and that's a right angle. I'm just going to draw one right angle in, and I'm going to draw it in right here. And we are going to be able to find MN using this triangle and the Pythagorean theorem. So this is like the hypotenuse C, and these can be A and B. So we know that C squared equals A squared plus B squared. So C squared equals 8 squared plus 6 squared, and that is 64 plus 36. So C squared is 100, and then C is the square root of 100, positive, so C is 10 for this one. And then in our problem, we know we're actually asked for NP, but we know that MN and NP are equal. So NP is equal to MN, and we just figured out what MN is. MN was 10. This is 10, and so NP is also 10. So make sure that you write good notes about that as you go. Now, our next part is the multiple choice, and we are going to do those problems as part of this section. So let's look at the multiple choice here for this problem, or for this section. So here are the problems, and I'll pause at them. There's quite a few. In class, we'll be using a handout, the blank handout, to set up these problems, and then we'll go over them. So here's 1A. Pause this if you need to. Moving on, here's 1B. Pause it again if you need to. Moving on, here's number 2. You need to graph that and show that it's a trapezoid using slope, and then decide if it's an isosceles trapezoid using the distance formula. Moving on, here's number 3. Pause this if you need to. Moving on, here's number 4A. Pause this if you need to. Moving on, here's number 4B. Pause this if you need to. Moving on, here's number 1. Pause this if you need to. Moving on, here's number 2. Pause this if you need to. Moving on, here's number 3. Pause this if you need to. Moving on, here's number 4. Pause this if you need to. Moving on, here's number 5. Pause this if you need to. Moving on, here's number 6. Pause this if you need to. And now you should write your questions and summaries. And there will be a part 2B where we'll go over these problems. And so this concludes part 2A. And then you're going to do these multiple choice, write your questions and summaries, and then we'll go over them in part 2B.